Thank you very much for joining today's session. Today we are going to discuss about the identification of iron. We have already identified the iron in flame test, but in that case we didn't confirm which ion we are identifying. It is ferrous ion or ferric ion. As you already know that there are some transition metals which can utilize their both valences for making the compound. When we had been discussing in our last session about the classification of inorganic compounds, there we found in binary ionic compound some transition metals can form their compounds by using both of their valences, like copper, like manganese, like iron. We have found iron 3 compound, iron 2 compound, as well as copper 1 or copper 2 compound. And depending on their balances, the way of names, way of making their names are different. Say when iron is using the valence 2, we need to mention their valence, iron valence, by using the Roman letters, Roman numeric, like 2 or 3. Similarly for copper, so we call it iron 3 chloride or iron 2 sulfate or ferrous sulfate or ferric chloride. So here we are going to identify the ion of iron present in the sample. As we have already learned, iron has two ion. One is iron, one is ferrous ion, and another one is ferric ion. So I'd like to identify the existence of ferrous and ferric ion present in compound, present in samples. The name of today's experiment is identification of iron 2 and iron 3 ions. The objectives are to design an experiment to determine if an unknown solution contains iron 2 or iron 3 ion, to organize the data collected in a chart. Learning objective to list compounds useful in identifying the iron 3 and iron 2 and iron 3 ions, to learn how to confirm the presence of iron 3 and iron 2 ion. There are several methods which we can apply to find out the existence of various iron ions. Usually in the laboratory you can carry out the experiment by using both of the techniques, both of the methods. Here usually we make the aqueous solution of iron compound, and then we make an identification reagent. Identification reagent means the solution which is used for identifying any of the chemical substances or part of the chemical substances. Earlier in the anion de-identification, anion detection, you have already been experienced about the use of identification reagent. It could be ammonium hydroxide, it could be some chloride solution. Different types of solutions are used for identifying the substances or part of the substances in a compound. So those are called identification reagent. Here we are going to use the identification reagent as a potassium ferrocyanide. Here you can see that the potassium ferrocyanide, and this potassium ferrocyanide, in addition to the iron 3 containing compound and iron 2 containing compound, will evolve with different color intensity, and depending on the intensity of the color we can identify the presence of iron 3 ion and iron 2 ion. Usually when iron 3 containing compound, like here that we have taken ferric chloride as the sample, and if we add potassium ferrocyanide, the blue precipitation, Prussian blue, that means very dark or intensified blue solution will be produced, which is the representation of iron 3 ion. On the other hand, when the same identification reagent will be added to ferrous sulfate, that means iron 2 sulfate containing compound, and we will find some precipitation of pale or light blue. That means it's light, depending on the intensity. Here, the high intensity and the lower intensity, we can identify the valence of iron. Simple apparatus required: beakers, test tube, stirring rod, spatula, and substance or the reagent or the material that required to conduct this experiment. Iron, the sample, we have taken ferric chloride as iron 3 compound and ferrous sulfate as iron 2 compound, potassium ferrocyanide as identification reagent, and definitely for making the aqueous solution of all these compound, usually deionized water, and if not, then we can use distilled water as well. On the other hand, we can also conduct this experiment by using sodium hydroxide test and ammonia test. Here, if you add sodium hydroxide to the iron 2 containing substance, a green, not the clear, very a little bit opaque green precipitation will be formed. And upon addition of excess sodium hydroxide, the dirty green precipitated remains insoluble. That means that is insoluble in sodium hydroxide even. And in the case of ammonia test, if you add a few drops of ammonium solution, a green precipitation. So similarly, another green precipitation will be formed, and addition of excess amount of ammonia solution, the green precipitation will be insoluble. So this is the identification test for iron 2 ion. On the other hand, if we take the sample containing iron 3 ion, and if the sodium hydroxide is added there, a reddish brown precipitation. Earlier it was a dirty opaque green precipitation. Here it will form a reddish brown precipitation, and addition of excess sodium hydroxide, that will be insoluble. So here also, similarly, depending on the color formation by the respective compounds, we can identify the presence of iron 2 and iron 3 ion. And here also, when ammonia solution is added to the sample, it will produce reddish brown precipitation, and in addition of excess ammonia solution, the precipitation will be insoluble. These are the methods can be used for identifying the iron 2 or iron 3 ion in the sample. So as usual, we'd like to share the demonstration. That is how we can carry out this experiment in the laboratory. I'd like to share the demonstration with you so that you can understand about its technique and procedure.
Solutions containing iron 2 ions are typically pale green in color. Compare this iron 2 sulfate solution to a colorless solution like that of aluminum chloride. First off, we may use the sodium hydroxide test to test for the presence of iron 2 ions. To a small sample of a solution, add a few drops of sodium hydroxide solution. You will notice that a dirty green precipitate forms immediately. Proceed to add an excess of sodium hydroxide solution. You will notice that the dirty green precipitate remains insoluble in excess sodium hydroxide. You may also use ammonia to test for the presence of iron 2 ions. To a small sample of the solution, add a few drops of ammonia solution. Notice that a green precipitate forms. Shaking the test tube may sometimes give a false impression that the green precipitate dissolves in solution. What actually happens is that the green precipitate is dispersed into finer particles throughout the solution. To obtain a clearer result, continue to add excess ammonia. If the result is clear, the green precipitate remains insoluble in excess ammonia. Solutions containing iron 3 ions are typically red-brown, orange, or yellow in color depending on the concentration of iron 3 ions. To test for the presence of iron 3 ions, we may employ the sodium hydroxide test. To a small sample of your solution, add a few drops of sodium hydroxide. You will notice that a reddish-brown precipitate forms. Proceed to add excess sodium hydroxide solution. Notice that the reddish-brown precipitate remains insoluble in excess sodium hydroxide. Next up, we have the ammonia test. To a small sample of your solution, add a few drops of ammonia solution. Notice that a reddish-brown precipitate forms immediately. Proceed to add an excess of ammonia solution into your test tube. Shake your test tube to ensure thorough mixing. Notice that the reddish-brown precipitate remains insoluble in excess ammonia.